Hello everyone, my name is Josephine Jandakwa and I'll be taking us through arterial blood gas test interpretation. First of all, what the ABG test seeks to do is that it measures the level of carbon dioxide, oxygen, the physiologically active gases in the blood, as well as measures the pH balance of the body. And so for the purpose of this study, I'll be dealing with three parameters: the pH, the partial pressure of carbon dioxide, and the bicarbonate levels. So let us look at the normal ranges for these. So the pH, the normal range is 7.35 to 7.45. So anything less than 7.35 is moving towards the acidic side. Anything more than 7.45 is moving towards the alkaline side. Looking at the pH scale here, the absolute pH of the human body, the blood, is 7.40. So even with the normal range, anything which is more than 7.35, be it less or more, which is below 7.40, is termed acidic. So you remember primary, we had a number line. So any number which falls here, be it 7.34, 7.33, they are all in the normal range though, but they're on the acidic side of the normal range. You understand? Yeah, and anything above 7.45 is considered alkaline. But even if it's between 7.35 and 7.45, and it is more than 7.40, which is the absolute, it is also termed to be on the alkaline side, just that it is still normal. You need that one in defining what is fully compensated and so on. We'll get to that one, but for now, let's look at the normal ranges. So that's for the pH. And the partial pressure of carbon dioxide, the range is 35 to 45 millimeters per mercury. But I brought a 45 first. You know why? Because the more carbon dioxide you have, the more acidic the blood becomes, because carbon dioxide will combine with water in plasma to give you carbonic acid. So for this one, the range is 35 to 45. But looking at what I've written here, acid to alkaline, I can't bring 35 here because the less carbon dioxide you have, the more alkaline the blood gets. And the more carbon dioxide you have, the more acidic it gets. That is why for carbon dioxide, I interchanged the values and made it 45 to 35. So anything above 45, you realize the blood is getting acidic. Anything below 35 is getting basic. You understand? Yeah, and the bicarbonate levels towards 22 to 26 milliequivalent per liter. Yeah. So someone may ask, in case you request as a doctor or a clinician or anyone at all, you are giving the ABG test results, asked to interpret. Normally, we interpret based on whether the person has acidosis or alkalosis. And the acidosis or alkalosis, it can be said in terms of whether it's metabolic or respiratory. We know the byproduct of respiration is what? Carbon dioxide. So the partial pressure of carbon dioxide here is the respiratory component. So let me put R in brackets here so that we get it. Then the bicarbonate, the byproduct of metabolism in the human body is bicarbonate. So the HCO3 here is the metabolic component. You get it? So this will determine whether a person has respiratory acidosis, metabolic acidosis, or whatsoever. But remember that the bicarbonate in the blood serves as a buffer. You understand that, to bring a balance with respect to the acid and bases. So imagine you've been given the test result, asked to interpret. How are you going to go about it? So right now, what we are going to use is that we are going to use a method called the tic-tac-toe method. I don't know how many of you know that game, tic-tac-toe, but it's like, let me do something roughly here. It's like something like this. So the three shapes, someone has circles, someone has triangles, someone has squares. And so let's say Amma has circles. If Amma is able to arrange her shapes in the same plane, be it vertically, horizontally, or diagonally, she wins. You get that? This is the same knowledge we are going to apply with respect to the tic-tac-toe method for interpreting ABG gas test. So the column which gets filled first, or which gets fully filled, becomes your primary condition, or is what wins. Something like that. You solve examples so that you get to understand what I mean by that. And for my GE fellows, maybe you don't know tic-tac-toe. Don't worry. There's another one synonymous to that known as Quesada Franca is also like that. Actually, someone would be dealing with brooms, another with papers. And in the same way, arranges them on the same plane and wins. So we are going to take some examples, and I think that will make the understanding of this one better. Yeah, so this is the table. And as I explained, the tic-tac-toe, there are 9 spaces. As I said, 3 people play it, and the column which wins, that is what we are dealing with primarily. So we have the first column will be for acid, the second column will be for normal, and the last column will be for what? Alkaline. So this is the tic-tac-toe method. Let me write it here. Don't mind my handwriting, no. Yeah, so let's take some examples, and that will make all that I've said more understandable. So for my first example, let's say you're being given results. You realize the person has a pH of 7.28. The person has a partial pressure of carbon dioxide of 51. Then bicarbonate levels of 24. Now let's fill our table. The pH is 7.28. From our normal ranges, it's less than 7.35, meaning it's acidic. So you can't place pH in the acidic column. Now let's move on to CO2. CO2 is 51. From this, you realize that it is above 45. And as I explained earlier, the more carbon dioxide you have, the more acidic the blood gets. So meaning PCO2 is also on the acidic side. So you can't place it here. Now, HCO3 is 24. The normal range is 22 to 26, meaning HCO3 is normal. So you can't place the HCO3 at the normal side. Now, look at this. As I said earlier, which column won? Or which column, was fully filled? It was acidic column, meaning we are dealing with what? Acidosis. But how do we know whether it's respiratory or metabolic? Now, which parameter completed the acidic column? That is the respiratory parameter, PCO2, meaning we are dealing with respiratory acidosis. And now I told you HCO3 acts as a buffer. If you are dealing with respiratory acidosis, what is HCO3 doing? From the table, realize that HCO3 is normal, it's in the normal range. In other words, it's not doing anything to help out the condition. So this condition, we will term it as uncompensated. Because if the HCO2 were to be helping out the current state, it would have been doing something. In other words, it would have been showing working. But looking at this one, it's not doing anything. So it's uncompensated respiratory acidosis. That is for this condition. I hope you understand. We'll take some other examples, and I think that will help us understand it better. So, the second person has a pH of 7.28, PCO2 of 51, and HCO3 of 32. Now let's fill it again. pH is 7.28. From our normal range, is also acidic. So you can't place pH here. PCO2 is 51, also acidic because it's more than 45. So you place PCO2 here. Now the HCO3 is 32. The normal range is 22 to 26, meaning it's on the alkaline side because it's more than 26. So you can't place HCO3 here. Now look at that. You realize that which column is fully filled is the acidic column, meaning still we are dealing with what? Acidosis. Is it respiratory or metabolic? You realize the respiratory parameter filled it, meaning we are dealing with respiratory acidosis. However, the bicarbonate levels are not normal. The bicarbonate is in the alkaline column, meaning, and we know bicarbonate is a metabolic component, meaning there's also what? Metabolic alkalosis. But I told you the primary situation is the column which is fully filled. So we are dealing with the primary respiratory acidosis with a secondary metabolic metabolic alkalosis. In other words, this respiratory acidosis, which is primary, is being partially compensated for because the bicarbonate has realized that the body is in respiratory acidosis. Let me do something to help the situation since it's a buffer. So it has raised its levels, you get it, in order to bring pH to normal. But as far as pH has not come to normal, it is not full compensation, it is partial compensation. So for this, you can say it's either a partially compensated respiratory acidosis or primary respiratory acidosis with secondary metabolic alkalosis. I hope you get it. We'll take another example and so our next example, the person has a pH of 7.39. PCO2 is 48 and ACO3 is 30. Now let's fill the table. pH is 7.39. From our normal range is 7.35 to 7.45, meaning pH is normal. PCO2 is 48, which is acidic because it's more than the 45. So PCO2 is here. ACO3 is 30, which is alkaline because it's more than 26. Wow. So now what do we do? Because now the column is not fully filled vertically, rather horizontally. So who do we give it to? This is where the pH scale I brought comes to play. Realize that now the pH is normal, but we know the absolute normal is 7.40. You get that? So now, the pH is going to be the determinant, whether metabolic or respiratory range. So pH is 7.39. From the scale, 7.39, if it were a number line, it would be somewhere here. Meaning it's on the acidic side. So here we are dealing with acidosis. But how do we determine whether it's respiratory or metabolic? Now, since we are dealing with acidosis, let's come to the acid column. Which parameter is there? Respiratory component. So it's respiratory acidosis we are dealing with. But as I said, the alkaline 2 is not normal. The HCO3 is not normal. It's at the alkaline side, meaning there's also what? Metabolic alkalosis, which is secondary to the primary respiratory acidosis. But as I said, since the pH is normal, we understand that what HCO3 or the acid-base balance and everything is to bring pH to normal. And since pH is in the normal range, you realize that this situation is being fully compensated for. So for such a situation, you can say it's a fully compensated respiratory acidosis, or in other words, a primary respiratory acidosis with a secondary metabolic alkalosis. But remember, anytime you see pH is normal, that is in the normal range, meaning the situation is fully compensated for. I hope you understand. Let's take the last example. All right. So the last example, the person has a pH of 7.44. PCO2 is 48. HCO3 is 30. Now, pH is 7.44. From the scale 7.35 to 7.4, meaning it's normal, right? Yeah, but as I said, let's come here. No, that will be for the interpretation. So 7.35 to 7.45. pH is 7.44. So it's normal, it's in the normal range. So you're going to put pH here. Now let's go to PCO2. It's 48. It's more than 45, which is on the acidic side. So PCO2 is acidic. Now let's go to ACO3, 30. It's more than 26. So it is at the alkaline side. Now again, I told you when you get the values filled or the parameters in a horizontal form, the pH becomes the determinant. It's normal. You get it? So now the pH, let's go to our scale. We know the absolute is 7.4, and now we are having 7.44. So looking at the scale, though it's normal, is on the alkaline side of the normal. You get it? So we are dealing with alkalosis here. And now, as to whether it's respiratory or metabolic depends on the parameter at the alkaline side, which is HCO3. So we are dealing with metabolic alkalosis. And I told you earlier, as far as you see pH is normal, this situation is what? Fully compensated for. So you can say this is a fully compensated metabolic alkalosis, or in other words, you realize that PCO2 is acidic. So meaning there's a secondary respiratory acidosis. You realize that, which is trying to help out the primary metabolic alkalosis, or in other words, compensate for it. So if you don't want to use fully compensated, you can say there is a primary metabolic alkalosis with secondary respiratory acidosis. But never forget that as far as pH is normal and these two parameters are on either side of the table, you realize that the situation is being fully compensated for. I hope you understand it. Yes. So that's it about the ABG test interpretation with respect to acidosis, alkalosis, and whether it be respiratory or metabolic. So I'm going to give a last, that this is somehow like a try test for you to know whether, to test your understanding of this. So briefly, I'm going to read out something, but I'll try to stick to the important part. So 56-year-old Mr. Kwesi Bentum came to your clinic this morning on account of progressively worsening dyspnea. He has a 7-year history of COPD and positive smoking and alcohol history, and so on and so forth. But at the end of it, you asked him to have an ABG test, and the results came, and the results were as follows. So his pH was 7.28. His PCO2 was 65, and HCO3 was 36. Now you can pause the video and solve it to see whether you understand. But all the same, I'm going to give the answer, which I'm not going to solve because I want you to solve it and test your understanding of it. He's going to have respiratory acidosis, which is partially compensated, or in other words, he's going to have primary respiratory acidosis with secondary metabolic alkalosis. So that's it for this video, and I hope you enjoyed the video. Thank you very much.